Now, in the last video, we talked about solving quadratic equations using factoring, right? Which is a great method. Unfortunately, not all quadratic equations factor. It doesn't take much imagination to come up with a quadratic equation where, you get it set equal to 0 and it doesn't factor. Well, what do you do? Well, possibly you could use what's called the square root property to solve it. Right now, this is for very, very specialized quadratic equations, so this doesn't work across the board. It works in a specific instance. But if you recognize your quadratic equation as this type that we could solve using the square root property, it's very fast. It's a quick way, probably one of the quickest way of solving a quadratic equation. And these we do run into pretty frequently. All right, so let's first of all talk about what the square root property says. It says if you have an equation, and this is a quadratic equation, x squared equals some number, right? It could be any number, positive, negative, or 0. X squared equals a number. Then we say the solutions to this equation are x equals positive or negative square root of this number. So, for example, something real simple. Say I have a quadratic equation that says x squared equals 16. Well, if you think about this, if x squared equals 16, what number taken to the second power is 16? Well, 4 taken to the second is 16, but so is negative 4. Or we could just say, well, we have x squared equals a. Therefore, what does x equal? It equals plus or minus the square root of a. Plus or minus the square root of 16 gives us plus or minus 4, which are the solutions to this quadratic equation. Now, that brings us to the issue. You can't always use this square root property. There are only certain types of quadratic equations that qualify to use the square root property. And that's what I have here with this little asterisk. This can only be used if the b value, the linear coefficient, is 0. Because you notice we have the quadratic term. We also have a constant, but notice we don't have that linear term, the bx. If that is missing from your quadratic equation, that's good news. If it's missing from your quadratic equation, you can use the square root property to solve it. So if I have something like, I guess this up here, notice I'm missing the x to the first term. There is no x to the first. Now you got two constants, but we could easily combine those when we start moving stuff to one side of the equation. That's not a problem, but you are missing that x to the first term. So if x to the first is missing, that is very good news. You can use the square root property. However, if you have something like we had in the last one, x squared equals 12 minus x, because of that x to the first, you can't use the square root property. Right? So it's for specialized quadratic equations, but understand, when you can recognize when we can use this, it's a huge time saver because they solve pretty easily. Right? Now, there is still a step-by-step process, but it's not difficult to your solution. So, case in point. You have 3x squared minus 17 equals 7. This is a quadratic equation. How do I know? The x squared tells me so. It's the highest power in this equation. It's quadratic. Okay, now, if I wanted to solve this by factoring, I would get this thing set equal to 0. Well, I notice in this particular quadratic equation, I'm missing x to the first. Good news. Since I'm missing x to the first, I can solve it using the square root property. But the idea is, in order to solve it using the square root property, it better be looking like this. In other words, there better not be a number in front of here except for 1. So a 1x squared equals some number. That's the only acceptable way we can apply the square root property. So I have 3x squared minus 17 equals 7. In my first step, what I'm going to have to say, I'm going to apply the square root property, which I am because there's no linear term. I'm going to say isolate your quadratic term. So isolate the quadratic term and then isolate the quadratic itself, x squared. Get x squared by itself. So how would I get x squared by itself? Well, the same way you would get x by itself, solving that very, very simple algebra 1 equation. You would add 17, you would divide by 3. Well, how do you get x squared by itself? You add 17, you divide by 3. So 3x squared minus 17 equals 7. I would do this in 2 moves, obviously. Add 17 to both sides for a 24. And let's divide both sides by 3. So x squared equals Right? So now I'm down to x squared equals some value a. In this case, the value a is 8. Now the square root property, we can apply it. So step 2, just apply square root property. Right, here's how we're going to say it. If x squared equals 8, then I know for a fact x is equal to plus or minus the square root of 8. Now, you just have one more cleanup step here. If that's a simplified square root, then fine, there's your answers, plural, because it's plus or minus. There are 2 answers here. If it's not simplified, well, you got to simplify that. So let's just say step 3, it's cleanup. Step 3, simplify. Simplify your solutions. All right, so the square root of 8, what are you? Well, that would be plus or minus, largest perfect square is 4. Going back a couple sections, that will be plus or minus 2. Square root of 4 is 2. Square root of 2, and just like before, plus or minus 2 square root of 2. We'll do the fancy braces to signify our solution set. Right? Now, keep in mind that is 2 solutions we have here. 2 square root of 2 and negative 2 square root of 2 are both solutions to this quadratic equation. We solve this quadratic equation using the square root property. So it's a very quick method, and what you have to understand, factoring is fine when things factor. If I would have tried to solve this thing by factoring, it would not have worked, because when you solve by factoring, you get rational numbers. You don't get radicals or square roots, irrational numbers in your answer when you're solving by factoring. Right? So, it's not like we can just say this one method we're always going to use. We want to kind of make our life as easy as possible, and like sometimes methods just aren't, you can't use them. Square root property is one case. You better be missing your linear term. The b better be equal to 0 to use your square root property. If it is, that is good news. It's very easy to solve. Okay, let's just try a second example here. Let's see what I got. I have x squared plus 5 equals negative 27. Okay. First things first, just going down our list. Yes, this is a quadratic equation because of the x squared. I just want to keep refreshing your memory about that because it's important to recognize you have a quadratic equation. Other equations, other types of equations have different methods of solving it. All right, next thing I notice, I am missing my linear term. There is no x to the first to be found in this equation. So that's good news. I'm going to use the square root property, which means I got to get it looking like this. It's got to be x to the second equals a number. No exceptions. So I'm going to subtract 5. In other words, I'm going to isolate my x squared, and this was just one step and done. So I get x squared equals negative 32. Well, there you go. Step 2, now you apply the square root property. You have x squared equals a number. Well, then x has got to equal plus or minus the square root of that number. So plus or minus the square root of negative 32. Okay, and then step 3, well, you need to clean up this answer. And this one definitely needs to be cleaned up. Number 1, you got a negative there, which means we're talking imaginary, but one step at a time. Let's separate the imaginary part from the rest of the problem. Now, square root of 32, the largest perfect square that divides into 32 is 16. And 16 times 2 is 32. Dividing this up very specifically. All right, so cleaning this mess up. That, of course, is I, plus or minus I. Square root of 16 is 4, and the square root of 2, well, it stays the square root of 2. I would write this as plus or minus, I'll write the 4, then the I, then the square root of 2. So, solution set, plus or minus 4I square root 2. And that's solving using the square root property. Right? Pretty easy method, all things considered. If you can recognize quadratic equations where this applies, you can save yourself a ton of time on factoring or other methods that we'll talk about. What happens when it doesn't factor? What happens when you can't use the square root property? Well, there's got to be another method out there, and good news, there is. We'll talk about it in the next sections there.